And in the last video for the Chapter 13 review, let me go through the process of solution dilution calculation. Very common technique. It's used in many different labs, not just chemistry, but also biology, environmental studies, microbiology, molecular genetics. The basic idea, if you have a concentrated sample, a stock solution, this is usually a high concentration, small volume, and then your final one, this is a low concentration. This would be the concentration you would use. Or in the case of the orange juice, this is what you use for breakfast, whatever. That's what you drink. The lower concentration in a lab, that's what you would use in the experiment. And so usually we let the ones equal the values associated with high concentration and the twos associated with what we use in lab, the low concentration. But honestly, it doesn't really matter. You can cross these up if you want to. I'm going to stick with this pattern. So if I look at my problem here, well, look at the two different concentrations. 6 versus 1.2. Well, this is a low concentration. So I'm going to say, well, this is going to be my M2. This is the volume associated with the lower concentration. This is my V2. That leaves the 6 molar concentration, my M1. And then what I want to know, how much, well, it's the volume of the M1. So that's V1. So I need to solve for V1 here. Let's just do that. Right, if I want to solve for V1, I want to divide both sides by M1. Now I have my new expression. So V1 is going to be equal to M2 V2 divided by M1. Really, I'm ready to plug and chug. Let's do that, and I'll make a comment about units in just a second. So if I do the math on this, and just to be clear, right, so this is telling me I need to multiply these two together, and then I'm going to divide by the 6. And when I do that, I get 0.12 liters here. And that's your answer. Let's talk a little bit more about what's happening here, or see a few things to keep in mind. One thing, let's just go ahead and handle the sig figs. So if we look at our data for our sig figs, we have 2 sig figs there, 2 there, 3 here. Well, whenever you're doing multiplication and or division, it's the fewest number of sig figs that you want to use to dictate how you round off your answer. Okay, so 2 sig figs. Talk about units for a second. Well, notice that, right, molarity divided by molarity, these two are going to cancel out, and then I'm left with my liters right there. And that makes sense, right? I want to know the volume of the sample here. The main thing to worry about with units is just to make sure that the units agree when they cancel each other out. Now here the concentrations agreed, and in most of these problems, that's what you're going to see. Is the concentrations going to agree, they'll cancel out, and you're left with whatever volume. It could be liters, could be milliliters, it doesn't really matter, because it's really the only unit in this expression when you're solving for V1 or V2. The scenario is a little bit different when you're solving for one of the concentrations, and I won't do a particular problem, but let's just talk about the units on that in just a second. Okay, so let me just solve for M1. Okay, so that cancels out. Now I have M1 equals to M2 V2 over V1. Let's just insert some hypothetical units in this expression. Okay, let's say that the M1, and let's just use something a little different. Let's say the mass percent. You may see that in one of these problems. Let's say the original, or the V2 volume was in milliliters. And let's say the V1 volume was in liters. That's a problem there. If you run across this, you can't just simply plug and chug. Again, the units have to agree with each other. So to solve this kind of problem, what you'd wind up doing, and it doesn't really matter, let's say, convert the milliliters to liters. And then once you do that, then the liters would cancel each other out. And then you were left with a concentration, associated with the M1. And I could have just as easily converted the milliliters or the liters value to the milliliters and then plucked and shugged. But again, bottom line, units must agree. Must be the same units and volume before you can do the math. And that'll do it for the Chapter 13 review.